Right, a little while ago we looked at security precautions, specifically the risks that cookies had and DDoS attacks. We're going to finish that, like the whole security precautions section. I was admittedly putting this off because I knew I had to remake this PowerPoint, like the animations, which you'll see in a bit. So we're finishing off security precautions, and we're going to be covering in how encryption works, and we're going to just talk a little bit about the Computer Misuse Act. There's not too much there, to be honest. So, right, encryption. So, encryption is the process of encoding information in such a way that only the computer with the key can decode it. Now, this is obviously to protect any private data. So, the way it's encoded is with something called the public key, and then it is decoded with the private key. So those are just two facts to remember. This is like the basics. What I'm going to do is I'm going to show a basic example, just talking about the public key and the private key, and then I'll cover a few more things after, and then we'll do a more complex example as well, because it's a little bit hard to take in. So, and by the way, I do pander to my audience, so don't say I'm not nice to you. So let's take two users, right? We've got PewDiePie, and we've got this guy. So what happens is, if they want to communicate with each other, they have to form a handshake, and this means a connection has been established. They agree upon the public key, so that's the thing that encodes the data, and they both get it. Now the problem with this is everyone can see it, not just these two, but everyone can see it. So it's not very secure. So what they also have to do is make a private key. It's not exactly the same, but it helps decrypt the public key. I'm not 100% sure how it works. I know there's a lot of complicated math involved, but they make a private key that helps solve that math. So only user 2 has access. Only this man has access to the private key, and it will help him once the message is sent. It will help him decrypt it. So the message comes along here. I made an anagram here, and he's got the private key. It'll tell him this, and now there could be other people. It could be potential hackers trying to see what the message is, but it's very unlikely they'll have a private key or they get access to that, so they shouldn't be able to see it. And that's how encryption works in simple terms, really. A couple things to add to that are digital certificates. So every time a new electronic message is made, now I'm saying it's sending a message, so this could be an email, or it could just be like a message on social media. Now when we say send messages, it could also just be if you're like PewDiePie here is Google, and then when you access Google, they send you the web page, but for it to be secure, you have to go through this as well. So it's easy to think with communication, but anytime there's a server that sends you a web page, the same thing is happening. So yeah, a new digital certificate is made for every single transmission sent. You can actually view this, like if you just go on to, you know what, I might even just go on now. Yeah, here. So if you click on that padlock, there's a way to see it. I can't remember exactly. I know it's here somewhere, right? Otherwise, certificate issued, so connection secure. And you can see more information, and this is their certificate. So whole point is that it gives you a serial number which should be unique, and that serial number, it just certifies that it is legit, and then you'll get a different certificate the next time you visit that site. It should be unique every time. It has the date on it. Well, the date should be that today. Now who issued it, so which certificate for. Sorry, I'm lying about the serial number. It's unique to their certificate. It's not unique every single time you make one. So that SQA site I was just on, they would have a unique serial number for that page, but it doesn't become unique when it's sent to you. Sorry if that was confusing. We have a public key. So a public key helps the receiver encode a reply. We've already looked at that, and it's something called the digital signature. Overall, this certificate just helps you know who sent it. Now I want to talk about digital signature a bit more. It's to make sure it's authentic, to make sure you know who sent it, like I just said, and it has to be confirmed, so just so you know that it's made by the right person and it hasn't been altered in any way. Now that's really important as well. And the digital signature won't match if the document has been altered in any way, shape or form. And it's created through some sort of algorithm we're not going to talk about using the public key. We're not going to talk about it because I don't know how it works. Again, it's a lot of complicated math. So let's look at a more complex example. We've got sender and receiver here. So this was PewDiePie in the last example. Let's say, so what happens is step by step, communication is made. This is the handshake. And again, this could be Google or whatever sending you their homepage, and this is you. A digital certificate is created. Inside it is the serial number, the date, and who issued it. So if it's Google, they'll issue their own ones, but if it's a smaller site, you have a place like the amazingly named GoDaddy. It also includes your public key. So the public key, step 5, is given to the receiver here, and a private key is generated that matches the public key. Now I've just done, it'll be more complicated than this obviously, I've just done some simple numbers and they're all the same as you can see. So using the public key and some really complicated math I don't understand, a digital signature is generated. Again, I've just added more numbers at the end for this example. This is added to the certificate as well. The message comes over. As you can see, it's got a little digital certificate with it. And if it doesn't match, so the number is one off, 98979898. If it doesn't match, that means it's been tampered with and it's been intercepted and it could not be secure. It could be, so you shouldn't be accepting that. Like it'll actually, even if you're on a web browser, if that happens, a lot of the time your browser will notify you that the website is not secure. It could just be that they don't have a certificate, or it could be that it was intercepted like this. Oh yeah, so here's another video if you fancy watching it, which explains it a little bit more. I don't want to actually watch it right now. For Computer Misuse Act, I'm just going to storm through this. Computer Misuse Act makes it illegal to modify data on a computer or access it without permission. Basically, it makes hacking illegal. It also makes using malware illegal. Now, just a bit of a revision, I'm not going to talk about this much. Here's all the different types of malware. Malware stands for malicious software. That's enough to know for now, and there's a bunch of different types. I harp on about this quite a lot. How did it get started? So basically in 1988, Prince Philip got his email hacked because there was 2 guys watching somebody from BT type in a password and username. Like basically, if you typed in this password and username combination, it gave you access to anyone's emails in the world. And then so they just watched this, and then they hacked Prince Philip. The hackers got taken to court, and they were accused of stealing 1/8 of a penny's worth of electricity. Now that fell through because it was a ridiculous claim. What you're going to be fined for 1/8 of a pennies? Like they said that was how much it took to open the email. As a result, it gathered a lot of media attention, and 2 years later, the Computer Misuse Act was born. So they went and started looking into making this and making laws to keep people safe. You can, under the Computer Misuse Act, so obviously there's hacking, but on the malware side of things, if you spread malware, you can be convicted. If you create it, obviously you can be convicted then as well. If you supply it to other people to use on other people, you can still be convicted. And just owning it, not being infected by it, but if you own it, and you plan on maybe using it someday, you can be convicted. So just even having the possible intent of doing bad stuff with malware can get you convicted. So this is the legislation, right? There's a lot. There's pages and pages. I copied it all over and I cut it down from the government website, and even then it's still a lot. Basically, offence 1 is unauthorized access to computer material. Again, this is legal speak, and the max sentence can be given is 2 years in prison. In other words, in human speak, unauthorized access to computer material, you break the first offence if you access something you know you shouldn't be accessing. Now there was a really interesting case in the news a few years ago where a 15-year-old in the UK accessed the Pentagon's website, or like their system, and hacked into it. I don't think he deleted anything, but he accessed it, and then he was accused of breaking this, and the US wanted to fly him over, and the UK tried to keep him here because they said that he didn't know what he was doing because he was autistic. Now it's an interesting argument because they said he didn't know what he was doing and didn't break it because he was autistic, but on the other hand, he was smart enough and he was able to direct himself towards the Pentagon. So does that mean like he didn't know the severity of the situation, but then he was smart enough to hack into that? I still don't think the case has been resolved. I think that was honestly like 5 years ago or something like that. So just an interesting case to think about. On offence 2, so we've got offence 1 is just accessing something you know you shouldn't. Offence 2 is once you've accessed it, you then go commit a further crime. So you use, and then you see that information, and maybe you sell that information, or I don't know what else you do with it. You use the information that you see on a system for another crime. And so part of it is you need to be guilty of offence 1, obviously, and then before you're guilty of offence 2. There's like different layers of seriousness, and there's more years in prison as a result. So yeah. Third one is you've accessed it, you've seen that information to cause another crime. The next level up is you want to block legitimate users from accessing the system. So you haven't breaking it, just looking at it, just getting into the system is offence 1. Offence 2 is doing something with that data. The next offence is, the next level of offence is shutting that company down. And yeah, that's the most severe one, and you can face up to 10 years in prison for this. And that is everything from me. Right. Thank you very much. Bye.